Hello friends, today I am going to reveal some true facts of Earth, the planet. But first of all, I request you to please share and subscribe my channel for getting my informative true facts videos uninterrupted. Now Earth. Origin of the universe. The universe began about 14.4 billion years ago. The Big Bang theory states that in the beginning the universe was all in one place. All of its matter and energy were squeezed into an infinitely small point, a singularity. Then it exploded. The tremendous amount of material blown out by the explosion eventually formed the stars and galaxies. After about 10 billion years, our solar system began to form. Birth of the solar system. We know how the Earth and solar system are today, and this allows us to work backwards and determine from the Earth and solar system were formed. Plus, we can out into the universe for clues on how stars and planets are currently being formed. The nebular hypothesis. In cosmology, the nebular hypothesis is the currently accepted arguments about how solar systems can form. We have now discovered over 200 planets orbiting other stars. The processes that created our solar system have also created an uncountable numbers of other solar systems. The nebular hypothesis. A large gas cloud nebula begins to condense. Most of the mass is in the center. There is the turbulence in the outer parts. The turbulent eddies collect matters measuring meters across. Small chunks grow and collide, eventually become large aggregates of gas and solid chunks. Gravitational attraction causes the mass of gas and dust to slowly contract and it begins to rotate. The dust and matter slowly falls towards the center. Protostar. As a result of contraction and rotation, a flat, rapidly rotating disk forms with the matter concentrated at the center that will become the protosun. I am going to repeat this. As a result of contraction and rotation, a flat, rapidly rotating disk forms with the matter concentrated at the center that will become the protosun. The Sun. After sufficient mass and density was achieved in the Sun, the temperature rose to 1 million degrees centigrade, resulting in the thermonuclear fusion. H atom plus H atom is equal to He atom plus energy. Birth of the solar system. The enveloping disk of gas and dust forms grains that collide and clump together into small chunks and planetesimals. I am going to repeat this. The enveloping disk of gas and dust forms a grain that collide and clump together into small chunks and planetesimals. Protoplanets. Gravitational forces allow the inner planet to accrue and compact solid matter, including light and heavy atoms. Solar radiation blew gases, primarily hydrogen, helium, away from inner planets. These gases were collected and condensed into the gas giants, that is Jupiter, Saturn, Uranus and Neptune. Beyond Neptune, ice and frozen gases from Pluto, Sedna and Kuiper belt objects. Leftover debris forms comets and asteroids. The terrestrial planets built up by multiple collision and accretion by gravitational attraction. Giant outer planets grew by gas accretion. Meteorites gives us access to debris left over from the formation of the solar system. We can date meteorites using radioactive isotopes and their decay products. Bombardment from space. For the first half billion years of its existence, the surface of the Earth was repeatedly pulverized by asteroids and comets of all sizes. One of these collisions formed the Moon. Now, formation of the Moon. It is important. The giant impact hypothesis predicts that around 50 million years after the initial creation of Earth, a planet about the size of Mars collided with Earth. This idea was first proposed about 30 years ago, but it took calculations by modern high-speed computers to prove the feasibility. This collision had to be very spectacular. A considerable amount of material was blown off into space. but most fell back onto the earth. Part of the material from the collision remained in orbit around the earth. By the process collision and accretion, these orbiting materials coalesced into the moon. The early moon orbited very close to the earth. The early moon orbited very close to the earth. The early earth heats up. Three major factors that caused heating and melting in the early earth's interior: collisions, transfer of kinetic energy into heat, compression, and radioactivity of elements, that is uranium, potassium, and thorium. The core, about 100 billion years after initial accretion, temperature at depth of 400 to 800 km below the Earth's surface, reached the melting point of iron. In a process called global chemical differentiation, the heavier elements, including the melted iron, began to sink down into the core of the earth, while the lighter elements such as oxygen and silica floated up towards the surface. The global chemical differential was completed by about 4.3 billion years ago, and the earth had developed an inner and outer core, a mantle and a crust. Chemical composition of earth. Each of the major layers has a distinctive chemical composition, with the crust being quite different from the earth as a whole. Whole earth, Fe plus O plus Si plus Mg, 93%, crust Si plus O plus Al, 82%. Chemical composition of earth. Lithosphere, a strong rocky outer shell of the solid earth, including all the crust and the upper part of the mantle to a depth of 100 km, forms the plates. Asthenosphere, weak ductile layer of the mantle beneath the lithosphere, deforms to accommodate the motion of the overlying plates. Deep mantle beneath the atmosphere, 400 to 2900 km in depth. Outer core, liquid cell composed of mostly iron. Inner core, innermost sphere composed primarily of solid iron. Continent formed from solidified magma that floated up from the mantle. Oceans and atmosphere. Fluid and gaseous outer layer believed to have been created by outgassing of gases and fluid from volcanic eruptions in a process called volatile transfer. The evolving atmosphere. Right after its creation, the Earth is thought to have had a thin atmosphere composed primarily of helium and hydrogen gases. The Earth's gravity could not hold these light gases, and they easily escaped into outer space. Today, H and He are very rare in our atmosphere. For the next several hundred million years, volcanic outgassing began to create a thicker atmosphere composed of a wider variety of gases. The gases that were released were probably similar to those created by modern volcanic eruptions. These would include water vapor H2O, sulfur dioxide SO2, hydrogen sulfide H2S, carbon dioxide CO2, carbon monoxide CO, ammonia NH3, methane CH4. Note that oxygen O2 gas is not created by volcanic eruptions. Creating the oceans. It is hypothesized that water vapor escaping from the interior of the earth by countless volcanic eruptions created the oceans. This took hundreds of millions of years. Now, astronomers also hypothesized that comets impacting the earth were a major source of water that contributed to creation of the oceans. Remember that comets are best described as dirty ice balls. The earliest evidence of surface water on Earth dates back about 3.8 billion years. A billion-year-old Earth. By 3.5 billion years ago, when the Earth was a billion years old, it had a thick atmosphere composed of CO2, methane, water vapor, and other volcanic gases. By human standards, this early atmosphere was very poisonous. It contained almost no oxygen. Remember, today our atmosphere is 21% oxygen. By 3.5 billion years ago, the Earth also had extensive oceans and seas of salt water, which contained many dissolved elements such as iron. But most important, by 3.5 billion years ago, there was life on Earth. There was life on Earth. By 2.5 billion years ago, the continent had been formed. The density of the continental crust, 2.8 gram per cm3, is lighter than the crust found on ocean bottoms, 3.2 gram per cm3, show the continents rise above the ocean floor. A question that remains unanswered is, when did plate tectonic starts? When did plate tectonic starts? It is remain unanswered. In my next video, I will give some more details of our planet Earth. Thanks.